Hello, everyone, and welcome back to another Planetarium live stream. I am Jessica, I'm the director of the Planetarium, and with me tonight is one of our students who I will still let say hi.
Hello, my name is Braden. I'm a vocal music education major here at UMD.
I realize I said still let, they've been here a lot. You probably know.
Yeah, yeah, probably know me. Probably.
So apologies for last week. We were on spring break. There was a lot of technical stuff going on in the
Yeah,
planetarium. It just didn't work out, but it's fine.
yeah.
We're back here. We're very excited to be doing this show tonight. So for longtime viewers, you may know the show. We're going to be doing one of our herstory shows that, of course, was originally created by Lindsay, one of our previous planetarium students. But since it is Women's History Month, I like to bring it out and talk about it. So we're going to be looking at some of the amazing women who made some pretty big contributions to the field of astronomy, most of which people usually don't know about, which is very sad, but that's why we're doing this. So as I get everything set up, as usual, if you have any questions throughout the show, feel free to leave them down in the comments. Brayden is going to be keeping an eye out on those for me and will let me know as questions come up. But as always, there is a little bit of a delay between when we see questions and answer them on stream. So just be aware of that and we'll get to them as soon as we can. But with that, let's dive into the history of astronomy. And we're going to get started. Oops, wrong button. There we go. All the way back in the 2nd century BC with, I have to say, one of my favorite women that I learned about, Agalon. I always butcher the name. Agalanis, her. Um, she had such an incredible knowledge of the moon and moon phases that people just called her a sorceress because she was able to give predictions on what the moon was going to look like and what the moon was going to do. And I absolutely love that. She ended up having a full, like, group of women who worked with her, and they were all just kind of the moon sorceresses, and I love it. I strive to be called the Moon Sorceress at some point in my life. It's fantastic.
It's a really good name. It's a really good name.
Jumping up to the 4th century AD, we have Hypatia. She was actually a professor of astronomy in ancient Greece and taught mathematics and astronomy at local schools, gave public lectures on the topics. So she is one of the early kind of teachers of astronomy. Jumping forward again now to the 16th century, we reach Sophia Brahe. Now, you probably, if you've taken any astronomy courses or done any sort of dive into like the history of astronomy, you probably know about Tycho Brahe, who is Sophia's brother. Tycho, he's a story, but he's often credited with a lot of different things, including creating a very precise um, map of locations and positions of stars and other objects in the night sky, creating instruments to get those measurements. But what a lot of people don't know is he had a sister who actually helped a lot with all of this, but the work is always credited to just Tycho. In fact, one of Tycho's accolades is that he discovered a supernova, which is pictured here and is called Tycho's supernova. But it was actually the two of them that made that discovery. But again, she is often left out despite the significant contributions that she made to all of that work. Jumping forward again to the 17th century, we have Maria here, who actually authored a book that included new solutions for determining the positions of planets, which was a big thing at this time, trying to figure out when and where the planets were going to be at and being able to have good models to accurately predict that. So she authored a book that had new solutions to be able to do just that. And then we have Elizabeth here, who is called the mother of moon charts because, well, she did just that. She made lots of detailed charts of the moon and the features that we see on the moon. And then she and her husband also cataloged more than 1,500 stars in the night sky, cataloging their positions and brightnesses. And so you can see one of her moon charts here in the center, and then in the right is a artistic depiction of her looking through telescopes and doing that work. All right, jumping forward again into the 18th century. Nicole here is a French astronomer who actually predicted the return of Halley's Comet. We now know today that Halley's Comet returns roughly every 76 years, but that wasn't really known at that time. So she was one of the first to actually make the predictions of when it was going to be back. And as was often the case, people didn't believe her until, it happened. But yeah, she did that. Marie here established a catalog of 10,000 stars. Again, the catalog would have been of star names and positions and brightnesses. And keep in mind, this is all before, computers and modern telescopes. They had telescopes, but they weren't nearly to the level that we have today. So all of this stuff was by eye, cataloging and getting all of this information. And so the fact that she did a catalog of 10,000 stars by hand is pretty remarkable. We also have one of my favorite women, Caroline Herschel. Now, again, if you've heard the name Herschel, it's probably due to her brother, William Herschel. He is often credited with a lot of work, including discovering the planet Uranus. But what most people don't know is Caroline, who is William's sister, helped with that discovery, but it always gets credited to him. And I realized that I have actually been doing just that as well in our planetarium shows, and I feel very bad because I definitely just talk about William. Wow, that's fine. We're going to change that. Caroline was also responsible for discovering several comets. In fact, if you see a comet with the name Herschel in it, it is named after her and not William. She also created star maps, mapping the position of stars in the sky, and was the first woman to get paid to do astronomy. Next, we have Princess Charlotte, who participated in observations with astronomers in the French court and attended the first ever European Astronomy Congress. All right, now heading into the 19th century, Emily, French names, I never took French, translated Newton's work, the Principia, into French. Now, the Principia is, again, something that Newton wrote. It talked a lot about his laws of motion and gravity and was a really important work for physics and astronomy. And so she is responsible for taking that and translating it into French so that French speakers could have access to that work. Maria Mitchell discovered a comet in 1847 and also won a gold medal from the King of Denmark for that. Mary here observed the moon and created a list of all of the lunar features. And in fact, the naming system that is used to name all of the different features that we see on the moon was created by Mary here. All right, so now we're going to jump to the time frame between 1877 and 1919, and we're going to go to the Harvard Observatory because there were a lot of women that did important work at the Harvard Observatory during this time. Now, they are often referred to as the human computers because they were doing all of this computational work by hand. This was before electronic computers were a thing. Now, the Director of the observatory at the time was Edward Pickering. So this group of women that worked with him were often called Pickering's harem. I personally don't like that name, but that is a nickname that they often get. But they were responsible for doing the real science with the data that was taken by astronomers. These women were not allowed to use the telescopes. They weren't allowed in the observatory. They weren't allowed to do any of the work actually taking the images and taking the data. But what they did was they got those images and then they did the science. So all of the scientific work, all of the discoveries that were made with the data are thanks to these women, which personally, I think is a bit more impressive than just taking the pictures, but I may be slightly biased in that. Um, and also keep in mind at this time, this is before we had digital cameras and things. So the images were taken on glass plates, which we call photometric plates. And so you can see here them holding up some of these glass plates and kind of looking at them with a magnifying glass and taking notes and doing calculations by hand. So let's look at a few of these women. We're going to start off with Antonia. She actually published an early catalog of the spectra of stars. So a little bit of background here. Light comes in many different colors and in types that we don't see with our eye. Stars give off different amounts of different types of light. And so we take something called a spectra, which takes the light coming from the star and it spreads it out so that we can see all of those individual types that's coming from the star. And what she did is she took that and she published an early catalog of all of the spectra of known stars at the time, and actually started the work towards creating a classification system that uses the spectra, which we'll talk more about in just a minute. Jumping now to Wilhelmina Fleming, she helped with that classification system, taking thousands of stars and their spectra, and helped to create an early classification system of stars based off of the features that they saw in that spectra. And again, all of this is being done by eye, with things that look like this on the left. There were no color spectra at that time. It was all black and white, looking at things that looked just like this on these glass photometric plates. So Wilhelmina helped with the creation of that classification system, and she also discovered the Horsehead Nebula, which is pictured here. It's very pretty. All right, now on to someone I admire very much, Henrietta Leavitt. Her work was absolutely instrumental for the revolution in astronomy at that time. So a little bit more kind of background and context here. At this time, we did not know if the Milky Way, our galaxy, was the entire universe, or if there were other galaxies out there and our universe was bigger than just our own galaxy. We saw smudgy things in the sky that we called spiral nebulae. And so there was a big debate going on at the time whether those things were part of our galaxy or whether those were galaxies of their own. The problem, though, was in order to help figure that out, we needed to know how far away those smudges were in order to tell, are they inside our galaxy or really, really, really far away? And getting distances to things in the universe is extremely difficult. And the further away something is, the harder it is to get that distance. Well, what Henrietta did is actually discovered a way that we could get distances to those little spiral smudges that we saw in our night sky. She discovered a type of variable star called a Cepheid variable. So a variable star is a star that varies in brightness over time. And there's lots of different types. There's lots of different reasons that a star can do this. But she discovered a specific type, again, called Cepheid variables, and learned that they have, all Cepheid variables have the same properties. They all get to kind of the same max brightness. And because we know what that max brightness is, we can figure out the distance to the star because we know how bright it's supposed to be. When we compare that to how bright it appears in our sky, the difference between those two is because of the distance. The further away something is, the dimmer it's going to look to us. And so she learned and realized that we could use these Cepheid variables to get distances. And for the first time, we had a way to measure distances to these objects and to these spiral nebulae. And because of the work that she did with Cepheids, Edwin Hubble, who most people know about, because the Hubble Space Telescope is named after him, he was able to use this method that she discovered to determine that the Andromeda Nebula was actually not a part of our galaxy and was an entirely separate galaxy in and of itself. So without her work, Hubble couldn't have done what he did. And unfortunately, most people don't know about her, but they know about Hubble. So yeah, love Henrietta. A few more from our Harvard Observatory. We have Annie Jump Cannon, who took that stellar classification system that was started by Wilhelmina Fleming and helped to refine it down to the system that we still use today. So looking at the details that we see in people's spectra, sorry, was glancing at something. Looking at the details that we see in the star spectra, she learned that the different details we see can help to classify and catalog stars. And so we now break them into these categories called stellar classification, and they are O, B, A, F, G, K, M. And this is a classification that's still used today, with the O stars being the biggest and hottest and brightest, and the M stars being the coolest stars. Now, she didn't realize that this was associated with temperature. That actually was another fantastic lady that did that a little bit later on. But yeah, she created this classification system that is still used today, and then went on to classify tens of thousands of stars using this classification system. Again, all by hand. And our next to last is Cecilia Payne Gaposchkin, who actually discovered what the sun was made of, which is crazy. We know now, and it's taught pretty early on, that the sun is a big ball of hot gas, mostly hydrogen and helium. But before Cecilia, we didn't know that. Astronomers actually thought the sun was made up of the same stuff that the Earth was, rocks and metals and things. And so when Cecilia took that spectra of the sun, what you could see in this nice detailed one, which is not the level of detail that she had to work with, you can see that there are little black spaces where there's missing segments of the colors of the light. Each of those little missing segments comes from elements in the sun that absorb that specific wavelength of light. And this creates almost like a fingerprint on the light, because we can match up those missing segments, and that'll tell us exactly what the sun is made of. And so she did this for the first time and found that it was actually mostly hydrogen and helium, which was completely unexpected. Now, unfortunately, as with most of these women, she was not believed. No one thought that she was correct. It wasn't until a man redid the work and said that, yeah, that's right, that people finally started to listen to her. Although I will give him some credit, he does credit her in his paper as being the first to do it, but unfortunately no one took the work seriously until he did it. But it was Cecilia, in fact, who figured that out. Um, and then the last of our Harvard women is Muriel Seifert, who discovered the Ring Nebula, which is a fantastic thing to look at in the summer sky. So that is our Harvard ladies. And I'm going to stop and do a quick plug here because if you are interested in learning more about the Harvard Observatory ladies, especially Henrietta Leavitt, the theater at UMD, their spring show happening right now is Silent Sky, which is all about Henrietta and the other women working at the Harvard Observatory at the time. So I do have a link in the video description if you're in the Duluth area. The show will be running through the rest of this week. It is a fantastic one, and if the weather is good, we will be out after the show for telescope viewing. Not happening tonight or probably tomorrow night because we do have another winter storm heading our way. But there are shows through Sunday, so definitely check it out. It's a great production, and we love celebrating these fantastic women. All right, finally, we're going to jump into modern day, starting with Elizabeth Alexander. She worked with radar technology during World War II that led her to become a pioneer in radio astronomy, which was a new field of astronomy at the time. Similarly, we have Ruby Payne Scott, who was also a pioneer in radio astronomy in Australia, and she was the first female radio astronomer. Elizabeth Roemer actually discovered 2 asteroids and discovered a moon of Jupiter named Themisto. You can actually see that's what the center image here is. This is one of the ways that we discover new moons and asteroids and planets and stuff. You take an image of the sky, and then you take another image at a different time. Stars aren't going to move between the 2 pictures, but something like an asteroid or a moon will have moved. And so you just take lots of pictures and you blink back and forth like this, and you see if anything's moved. And so using this technique, she discovered those asteroids, she discovered one of the moons of Jupiter. And she also collected data and information about comets and comet nuclei, which is the actual physical object that creates the comet. Eric here studied the atmosphere of stars and realized that it's actually a lot better to observe and learn about stellar atmospheres in not visible light, in using ultraviolet light. So what you're going to see here in this video is videos of the sun taken in different types of light. And so you can see, oops, let's play that again. You can kind of pick up different features and see different things in these different types of light. So yeah, she was the one that figured out that ultraviolet was the best way to study the atmospheres of stars. Oops, come on. Vera Rubin discovered dark matter. 3 words to her description, and it's a lot involved in that. So basically, when we look at stars as they move around the center of their galaxy, based off of how much stuff there is in the galaxy, how much mass, we expect the stars to be moving at a certain speed. Well, what we found out looking at the speeds of stars is they're moving a lot faster than they should be based off of the stuff that gives off light. So if we estimate the mass of a galaxy based off of how much light we're getting from it, and how much light emitting stuff there is, that's not enough to account for how fast these stars are moving. That must mean that there is a lot more stuff there that doesn't give off light, and that's dark matter. And Vera Rubin discovered that. She actually discovered that in clusters of galaxies, because galaxies are often grouped together in galaxy clusters. And she saw the same idea that the galaxies in the cluster were moving faster than they should be, so there must be a lot other stuff there that we can't see, that doesn't give off light. And again, as is common, she wasn't really believed at first until other people started finding the same thing. But yeah, discovered dark matter. Vera Rubin. Carolyn Shoemaker once held the record for the most comets ever discovered by an individual. And so any comet that you see the name Shoemaker, that's hers. And probably the most famous of them is Shoemaker-Levy 9, which is famous because it hit Jupiter. But yeah. Speaking of that, Rita here was an expert on the atmospheres of the giant planets like Jupiter and actually helped study the effects of when Comet Shoemaker-Levy 9 hit Jupiter. So yeah, pretty cool there. Jocelyn Bell discovered the first ever radio pulsars. So radio pulsars are objects in space that give off pulses of radio waves. And we didn't know what they were. She discovered them. In fact, for a while, they were called LGM for little green men, because it was just a joke. We didn't know what they were. They ended up figuring out that a lot of these are active galaxies. But yeah, she discovered this brand new class of object called radio pulsars that had never been discovered before. Nancy Roman was one of the first ever female executives at NASA, and she is often known as the mother of Hubble for her role in planning for the Hubble Space Telescope and getting that program going. So it's a lot thanks to her that we have the Hubble Space Telescope. Speaking of, another woman who helped with that was Margaret Burbridge here, who actually helped develop one of the instruments that is on Hubble. And she, a lot of things here. She showed that almost all of the elements in our universe are produced thanks to stars. So at the very beginning of the universe, when it first started expanding, it was hydrogen, helium, and maybe a tiny little bit of lithium. Everything else, all of the other elements that exist in our universe, were created either in the center, in the core of stars, during their life and death, or during things like supernova explosions, when a massive star dies. And she was the one to prove that and show that that was, in fact, the case. This is what we call nucleosynthesis. So kind of a really, really big deal for astronomy there. She also discovered that the galaxy M82 has a massive black hole at its center, what we call a supermassive black hole. And we now know that most, if not all, galaxies house a supermassive black hole at their center. But she found the one in M82. A few more. One of my more modern favorites here is Tabitha, who discovered an unusual star that we call Tabby star after her. Its brightness varies really erratically and really weirdly. So I've talked about these things called variable stars, stars that vary in brightness. And I said that there's a lot of different reasons that that can happen. Well, when Tabitha started looking at this star, none of the options explained what she was seeing. So it became just this really weird mystery of what's causing the star to have this very weird, chaotic, random changes in brightness. For a long time, it was joked about, again, that it was aliens, that they built this big structure around the star called a Dyson sphere. But we now think that the star actually has planets, and in particular has a rather big cloud of comets that orbit it. And those varying and random dimmings in brightness that we see are when those comets actually pass in between us and the star and block some of the star's light. And because it has just this big comet cloud, we get these what seem to be random variations in its brightness. But yeah, that's Tabby star. Um, and last, oh, it looks like my camera froze. Are we good?
I think we can still hear you, but your camera does seem to be frozen.
In a super flattering pose, I will add.
Yeah.
Um, let me see if I can adjust that. Anyway, we're right at
Yeah.
the end anyway. Last up is Katie Bowman, who actually created the algorithm that led to the first ever image of a black hole, which of course was released a few years ago. And it's all thanks to the algorithm that she led the creation of. And I believe that is the last of my amazing women in astronomy. So let me bring my Zoom back up, see if I can get my camera back. There we go.
It looks like it's working now. We do have one question, and the question is kind of a loaded one. I can't believe I've never heard of any of these women. How can astronomy properly attribute their discoveries? It,
Part of
by,
it's
by,
stuff like
uh,
this,
yep.
actually teaching about them, educating future educators so that they
Mhm.
know proper, who actually discovered things, and then they can teach that as well. I mean, I said earlier that I still in the planetarium have been saying William Herschel as the discovery for
Yeah,
Uranus,
yeah,
because I frankly forgot, and I feel real guilty about that. But we will make that change, because I definitely want to make sure that we do just that. And I will say, I talk about Henrietta Leavitt in particular a lot because I love her, and the work that she did. But yeah, it's doing things like this and making sure that that information is getting out there.
yeah,
So yeah,
yeah. Education. That's really all that can be done about it.
yeah,
Which is I think, kind of almost a frustrating response to that, because like you want to like make actual change, but like that it is that's the first step.
yeah.
Anyways, that's the only question. Oh, we got another. Yeah, no, just a comment.
Yeah, yep. So it's something, and I will say, I mean, there is definitely improvements.
Yeah.
I'm even seeing in like textbooks more mentions of these women in them as well.
Hmm.
But it's just continuing that work. So yeah, it's an
Yeah.
ongoing thing. But yeah, I'm glad I got to. I know there was a lot,
Yes.
um, but and it actually to me almost makes that more sad that there were so many women that I got to talk about that were very important, and yet
Yep.
people don't know about them.
Yep.
And I mean, there's so many more that can be added to the show as well.
Oh yeah. And it's an I think the most maddening thing is that it's in quite literally every profession as well.
Yeah,
It's not just astronomy, it's chemistry, it's biology, it's music, it's everywhere.
yeah,
It's
absolutely.
frustrating.
But that's why we
But
do what
do
we do.
this.
Yeah,
Yep.
yep. So hopefully, you can learn about some cool people. Maybe you can do some, look into some of them yourself, find out more. Yeah, because there's lots of cool stuff there. But, all right. Well, how about we'll do one last call for any
Mhm.
questions. While we do that, let me go ahead and throw up our schedule for the week. So the show, we're not going to have a public show on Friday because we have a special private event going on. But we will have shows on Saturday at 2 p.m. Our family show is Two Small Pieces of Glass, which is about telescopes. And then The evening general public show is Europe to the Stars, which is about big research observatories and kind of how astronomers use these big telescopes and some of the really cool things that have been discovered with them. And then we'll be back here next Wednesday for our monthly installment of Ask an Astronomer. And lastly, don't forget that Astronomy Day is coming up in a couple weeks, April 1st. It's going to be from 6 to 9 p.m. I've got a link in the video description if you want to go and find out more information about that. We're going to have planetarium shows, activities, telescope viewing if the weather cooperates. We've got some fantastic raffle prizes. Yeah, so all the information on our website. You can go check that out and hopefully come see us. It's going to be a really great night.
Yeah,
All
it'll be really
right.
fun.
Well, I'm not seeing any other questions, so I think we will
Mm-hmm.
wrap it up there. Thank you everyone so much for joining us. If you are in the Minnesota area, stay safe out there tomorrow. I know we've got our next winter storm hitting us tonight.
Yep.
So stay safe out there tomorrow. And yeah, have a great rest of your week. Bye, everyone.
Bye bye.